Hello students, in my last lecture I had given you information about graphical representation of motion. In that lecture we had seen rest motion, uniform motion and non-uniform motion. Today we shall try to learn how we can represent time and distance on distance time graph and how we can calculate speed also. So once again we see a distance time graph. Suppose this is a distance time graph. This is x-axis, this is y-axis, this is origin. We had seen that we take time on x-axis, so x-axis is also called time axis. Suppose time is given in minutes, because always it is not necessary that time will always be given in second. It may be in minutes, it may be in hours according to situation. So here time is given in minute and the unit of time 20, 40, 60, so on. So 20 minutes, 40 minutes, 60 minutes. And this is y-axis is called distance axis here. Distance is given in kilometer. And the scale of this distance axis is 1, 2, 3, 4, so on. So 10 kilometers, 20 kilometers, 30 kilometers, 40 kilometers. Suppose as per our requirement, this is our distance time graph. In last class we had seen that if distance time graph is a straight line, then it represents uniform motion, that is in equal time interval distance travel is equal. So from suppose this is our origin, and how we can explain the time taken and distance traveled. So from any point of this distance time graph, if we draw normal on time axis or x-axis, then that point gives us the appropriate time. So suppose from any point A, if we draw a normal here on x-axis and this line touches at a point T1 here, so this O and suppose it is A dash, OA dash gives us the time interval in which the object reaches a distance. Now, how much distance has been traveled? It is given by drawing a perpendicular on distance axis. So, if we draw perpendicular on distance axis from any point of this graph, then this point gives us distance traveled. Suppose this is distance traveled S1. Again from any point B, if we draw normal here on x-axis or time axis, then the point where it meets gives us time interval. So after time T2, what will be the distance traveled? Once again, from this point, we draw a perpendicular on y-axis. Suppose it meets at a point and this point is S2. So very technical thing it is, and it is very important to solve our numerical problems. So in time T1, this distance, in time T1 the distance traveled will be S1. In time T2 the distance traveled will be S2. So what will be the time interval in between T2 and T1. Here the time interval between T2 and T1, suppose it is T, it is given by final reading minus initial reading. Always in my last lecture also we had seen that any reading is calculated with the help of difference between final minus initial. Similarly, in time t, in time interval t, the distance traveled, suppose it is s, will be given by how much? S is equal to S2. See here, S2 minus S1. So this will be the distance traveled in this time interval. So it is given by S2 minus S1. And what we have read? We have already read that speed is equal to distance traveled divided by time taken. Therefore, here speed v is equal to how much distance is traveled? S2 minus S1, this divided by T2 minus T1. This is very important fact, and it will help us to solve our numericals. This is given in our NCERT page 104. And this article is given in our page 104 of NCERT Science Book of Class 9. Once again, the second thing is that with the help of distance time graph, what we can calculate? With the help of distance time graph, we can calculate a speed. How we can calculate a speed? On time axis, if we draw a perpendicular from this distance time graph on time axis, then this point gives us time, and if we draw a perpendicular from this point to y-axis, that is distance axis, then that point gives us the distance traveled, and already we know that distance divided by time gives us a speed. Now we shall consider velocity time graph. What is velocity? Dear students, a speed with direction is called velocity. So rate of change of displacement is called velocity. Now we shall see velocity time graph. Velocity time graph. Suppose we have given a situation according to which we always take time on x-axis. So this is x-axis, this is y-axis, x-axis, y-axis origin. In this case, suppose time is given in hour. We should learn every situations. And what is the unit of time here? The unit of time is hour, and a scale is hour, 1 hour, 2 hour, 3 hour, 4 hours, so on. So 1, 2, 3, 4. And velocity is given in kilometer per hour. And the scale on this axis is here. The scale on this axis is here how much? 1, 2, 3, 4. That is 10 kilometer per hour, 20 kilometer per hour, 30 kilometer per hour, 40 kilometer per hour, so on. Dear students, it is the time of lockdown. and road is completely clear. So suppose any medical staff, that is doctor with complete nursing staff, have to travel a long destination and there is not any problem of traffic, so the journey starts with 30 km per hour. After 1 hour also the same speed is maintained. After second hour also, because patient is with them, so they are not trying to increase their speed. What we see here? We see that time is going on, but the velocity is constant. So here, what we see? We see a graph. We meet all these points, and after meeting all these points, what we find? We see that here, this is velocity time graph, and it is parallel to x-axis. So if velocity time graph is parallel to x-axis or time axis, then it gives us constant velocity. Constant velocity. There are very important topics. It is also non-accelerated motion, because here velocity remains the same. Also, we had seen in last classes hour that if distance time graph, in our last lecture what we had seen that if distance time graph, see here, if distance time graph is parallel to time axis, then it represents rest. But here it is not distance time graph, it is velocity time graph. So if velocity time graph is parallel to time axis, then it is uniform velocity or constant velocity or non-accelerated motion. Again, suppose from this graph there are 2 points. At this graph we take a point B and we draw a normal from B to x-axis, and it meets at any point here D, and we draw a normal from any point A to x-axis, and it meets at point C. Suppose this is our point C and this is point D. In our last graph, what we had seen? We had seen that the point, every point on this axis gives us appropriate time. So suppose this time interval is t1 and this time interval is t2. So what will be the appropriate time taken in this from point A to B? So this time interval will be given by t2 minus t1. Here time interval will be given by t is equal to t2 minus t1, which is represented by how much? CD. This is equal to CD. We shall represent everything geometrically. So in class 9 we shall represent rest, motion, acceleration, uniform motion, non-uniform motion, speed, velocity, accelerated motion, non-accelerated motion, all these terms in the shape of graphs. So it is very, very important and technical chapter for your future journey of physics. Try to learn it with very great patience and also repeat it again and again for your actual learning. So see here, CD points, this point CD gives us the time interval. Why? Because OD is equal to T2 and OC is equal to T1. So OD minus OC, that is CD, gives us T2 minus T1. This is time interval. And with which notation we shall explain here velocity? Here velocity is given by AC or BD. So here velocity V, this is time. Velocity is represented, velocity V is represented by here AC, or this is equal to BD. Why? Because these are the opposite sides of a rectangle. We know that opposite sides of rectangle becomes equal. So in rectangle ABDC, AC is equal to BD and CD is equal to AB. So AC is equal to BD is equal to velocity. And also we know that displacement S is equal to velocity into time. So from this graph, velocity V is represented by AC or BD. So we can write AC and time by CD. See, what is the meaning of AC into BD? AC into C. AC into CD. AC into CD. It is area of a rectangle. From class 5 or 6, you have started to learn what is the area of any rectangle. Area of rectangle is equal to length into width. So suppose if here one side is AC and another side is CD. So area of rectangle ABCD is given by AC is equal to CD. This is equal to area of rectangle ABCD. With this concept, we can say that the geometrical area between velocity time graph and time axis gives us displacement. This is the geometrical area here. This is the geometrical area, and this geometrical area gives us displacement. This is very important fact which will be used during solving numerical problems and graphical proof of equations of motion. So we can write that what the displacement is given by the geometrical area between velocity time graph and time axis. This is very important fact. So try to learn it. Dear students, once again I shall suggest you that for proper learning, your active participation is very much required, because you are the people which are the main part of whole teaching learning process. We teachers are trying up to our maximum extent for your help to maintain our regular study during this lockdown time period. But if you are really taking part actively, then our effort will be fruitful. So before concluding my today's lecture, I shall give you once again home assignment. Learn and explain how we can give geometrically displacement with the help of velocity time graph. Thank you very much.